Hello everyone. Now we are going to take up p block elements. What is the meaning of p block elements in block classification of elements? What are the physical properties or the general characteristics of p block elements? So start with p block elements. Now, those elements, while writing electronic configuration, if the last electron or the differentiating electron enters in p orbital of the valency shell, then those elements are collectively known as p block elements. So, last or differentiating electron enters in p orbital of valency shell. So, when writing electronic configuration, the last electron, if this is entering in p orbitals of the valency shell, then those elements are known as p block elements. Now, look at this. P subshell has got three orbitals, Ex, Ey and Pz, and according to the rules of Pauli's exclusion principle, each orbital can have a maximum of 2 electrons with opposite spin. So since there are 3 orbitals in p subshell, so a total of 6 electrons can be placed in p orbitals. Now, since 6 electrons can be placed in p subshell or p orbitals, the total number of groups in p block is 6 groups. It consists of 6 groups because each subshell can accommodate 6 electrons. Since the total number of electrons that can be placed in p subshell is 6, so p block of this classification contains 6 groups, that is group 13 to group 18. These are the groups which is known as p block elements. Now, for these p block elements, the general electronic configuration of the valency shell is NH2 and P1 to 6 electrons. So electrons are progressively entering p orbital of the valency shell, where this N is valency shell. This is the number of electrons. Now we have this electronic configuration of p. So starting from the first electron entering in p orbital, that is, we can have p1, we can have up to p6. So we have these elements. So look at this, we have these groups, 13 group, we have 13, 14, 15, 16, 17, 18th group of the periodic table. These 6 groups are known as p block elements. 13th group electronic configuration NH2 NP1. So we have 1 electron in p orbital. NH2 NP2 NH2 NP3. This is group number electronic configuration NS2 NP4 NS2 NP5 NS2 NP6. So the p orbital is completely filled up here, 6 electrons. S orbital of the valency shell is completely filled up, and p orbital of valency shell is also completely filled. So this configuration having ns2 and p6, in which we have 8 electrons in the valency shell, this is known as octet. This group 13 element, this is known as boron family. The elements are boron, aluminium, gallium, indium and thallium. These group 14, this is known as carbon family. We have carbon, silicon, germanium, tin and lead. Group 15, this is known as Chalcogens or nitrogen family. Nitrogen, phosphorus, arsenic, antimony, bismuth. Group 16, this is known as oxygen family or chalcogens. Oxygen, sulfur, selenium, tellurium, polonium. 17, halogen family. We have fluorine, chlorine, bromine, iodine and astatine. Group 18, noble gas. We have neon, argon, krypton, xenon and the last one is, so these elements polonium, astatine, radon, these are radioactive. This group 13, this is boron family. Group 14 is a carbon family. Group 15, that is nitrogen family, also known as Chalcogens, because the hydrides of these group 15 elements are poisonous in nature, so they are known as Chalcogens. Group 16, these are known as Chalcogens. Chalcogens means ore forming substance, because in nature most of the metal ores are either in the form of oxides or in the form of sulfides, so these are known as ore forming substance. Group 17, these are known as halogens. Halogens means sea salt forming, because most of the salt that is available in seas and oceans, these are in the form of chloride, bromide, iodide or astatine. So these are known as sea salt forming elements. Group 18 elements, these are known as noble gas. Why they are known as noble gas? Because they have completely filled the valency shell, that is octet, 8 electrons in the valency shell. So since these orbitals are completely filled up, so their reactivity is very poor. Since the reactivity is very poor or very less, these are known as noble gas or non-reactive gas. So these are p block elements starting from p1 to p3. Now if you look at this, these elements, group 13, the number of electrons in the valency shell is 3. So let's find the number of electrons in the valency shell. Total we have 3 electrons in the valency shell, 2 plus 1. Group 14, 4 electrons in the valency shell. 15, 5 electrons. 16, 6 electrons. 17, 7 electrons. 18, 8 electrons in the valency shell. Now if you look at this number of unpaired electrons, number of unpaired electrons in group 13, we have one unpaired electron, that is P. Group 14, we have two unpaired electrons. Group 15, we have three unpaired electrons. Group 16, we have two unpaired electrons because the fourth electron undergoes pairing. Group 17, we have one unpaired electrons. Group 18, there is no unpaired electrons. All the electrons are completely paired. Now if you look at this P3 configuration in Chalcogens or group 15, this is half filled. So we have look at this is P. Each orbital is having one electrons, and all the electrons are having same spin quantum number, either they are in all positive direction or all in negative direction. So this is half filled, that is following the Hooke's rule. So we have these elements and their electronic configuration, number of electrons in the valency cell. Now for these P block elements, let's try to define the group number and periodic number, that is location of these elements of P block. So let's define for group number. Group number of P block element is equals to 10 plus number of electrons in valency cell, that is Ns plus N P electrons. Period number, that is equals to N of valency cell. The principal quantum number of the valency cell defines the period number. So this is how we locate these P block elements. Let me give you an example. So look at this, sulfur, atomic number 16. So let's write the electronic configuration. So we have 1s2, 2s2, 2p6, 3s2, 3p4. So if you look at this, so therefore the group number is 10 plus total number of electrons in valency cell S and p orbital. So this is the valency cell. So number of electrons in S is 2, number of electrons in P is 4, so 4 plus 2 6. So this comes out to be 16th group element. Look at this. We have the sulfur in 16th group. Period number, highest occupied shell, that is valency shell, is 3. So the period number is 3. So this element belongs to third period and the 16th group. So this is how we define the period number and the group number. One more example I will give you. Suppose an element has got 7 electrons in the valency cell. 7 electrons in the valency cell. So suppose we have this element X has got 7 electrons in valency cell, and this element belongs to third group. So we have an element X which has 7 electrons in the valency cell and it belongs to third group. We have to identify the element. So we have 7 elements. This is in third period. So since the period number is 3, so therefore the highest occupied shell, valency cell, is equals to 3. So highest occupied shell of this element X having 7 electrons in the valency cell is 3. So we have look at this, 3s2, 3p5. So we have 7 electrons, 2 electrons in s orbital, 5 electrons in p orbital. So we have 7 electrons. Third period, highest occupied shell is, so means before this all orbitals are completely filled up. So before 3s we have 2p6, before this we have 2s2, before this we have 1s2. So total number of electrons for this element is 17, that is electronic configuration. So this element X having 7 electrons in the valence shell which belongs to third period. So highest occupied shell is 3, and in this highest occupied shell we have 7 electrons, so this is 3s2 and 3p5. Now before this 3s2 and 3p5 all the orbitals are completely filled up. So according to electronic configuration of following above principle we have this configuration. So total number of electrons present in the element X is 17. So this is the atomic number of X. So X is 17, atomic number 17. Number of electrons is 7 in the valence shell. Since the last electron enters in p orbital, so this belongs to p block. So the group number is 10 plus number of electrons in the valence shell, that is 7. So this belongs to 17. So this element belongs to 17th group, third period, 7 electrons in the valence shell, atomic number is 17. This is how you identify the elements in periodic table: group number, period number. Now coming to general characteristics of p block elements. These p block elements consist of metals, non-metals and metalloids. Now if you look at this, S block contains only metals, D block contains only metals, but in between these two we have P block element which consists of metals, non-metals as well as metalloids. So if you look at this metals, we have, look at this, aluminum, tin, lead, these are some of the metals. Non-metals, look at this, we have oxygen, nitrogen, sulfur, chlorine, bromine, iodine, etc. And metalloids, we have, look at this, most common metalloids, that is silicon, germanium, etc. So this group consists of all different types of elements: metals, non-metals as well as metalloids. These p block elements forms mostly covalent bonds. Now if you look at this, S block elements forms only ionic bond, D block forms covalent as well as ionic, but these metals, non-metals or metalloids of these group elements, that is p block elements, they forms covalent as well as ionic, but mostly they form covalent compounds or covalent bonds. The elements of this p block does not show any color, Now while considering these metal, non-metal or metalloids, moving down the group, in any particular group, metallic character increases. Metallic character increases in any particular group, whether you have in 14 group, 15 group, 16 or 17 group. In any group, when we move from top to bottom, the metallic character increases. These elements shows, some of the elements shows variable oxidation state, modern 1 oxidation state. So there are elements which shows more than 1 oxidation state. The oxides of these elements, so we are considering oxides, the oxides of these elements, basic, acidic, amphoteric and neutral. So the oxides of P block shows all different types of oxides. Some of the oxides are basic, some of the oxides are acidic, some of the oxides are amphoteric, and some of them are neutral. So if amphoteric means showing both acidic and basic, both acidic and basic. So look at this acidic oxides, non-metal oxides. Non-metal oxides are generally acidic in nature. Example, we have carbon dioxide. So carbon dioxide is an acidic gas. So look at this, why this is acidic. So when this carbon dioxide is dissolved in water, this gives you carbonic acid. This is acid, which ionized to give you H plus ion and bicarbonate ion. So this results in the formation of H plus ion in solution. So this particular species known as carbon dioxide is acidic. Why? Because this, when dissolved in water, furnish to give you H plus ion. So any substance that furnish H plus ion in solution is what we call as acidic compound. We can also have look at this sulfur trioxide. When dissolved in water, this gives you sulfuric acid, which is known as king of chemicals. So this ion has to give you H plus ion and sulfate ion. So these are examples of acidic. Neutral oxides. So we have look at this. Neutral oxides means this does not react with acid or base. So there are some of compounds which does not react with acid as well as base. Those compounds are not neutral in character. So we have look at this carbon monoxide, we have nitrous oxide, we have nitrogen monoxide. These oxides, these are non-metal oxides, but this does not show acidic as well as basic property. Amphoteric oxide. The metal oxides of P block. P block contains a number of metals. So the metal oxides of P block shows acidic as well as basic. So let me take this example. Al2O3. This is aluminum oxide. Now look at this. This aluminum oxide reacts with HCl when this gives you AlCl3. Now this oxide is reacting with HCl. HCl is acid, strong acid. So if this reacts with acid, means this compound should be acting as a base. On the other hand, this aluminum oxide also reacts with sodium hydroxide. Sodium hydroxide is a base. So the substance reacting with base must show acidic character. So we have look at this. So this Al2O3 reacts with acid as well as base. So we say this is amphoteric in nature, showing both acidic as well as basic character. Take this SnO2, tin oxide. This again reacts with HCl as well as sodium hydroxide. So we have this HnCl4 plus H2O. So reacting with acid, this is basic in nature. This also reacts with base. Stannous oxide. So again look at this. This also dissolves in sodium hydroxide, which is a base. So this again acting as an amphoteric in nature. So most of the metal oxides of P block shows amphoteric property, that is acidic as well as basic. So these oxides, the basic character of these oxides increases down the groove. acidic character of these oxides increases from left to right. Take this example. You look at this Cl2O7 chlorine heptoxide. This is non-metal oxide. So look at this, when this is dissolved in water, this gives you a very strong acid which is known as HClO for perchloric acid. So look at this, Cl2 oxide when dissolved in water gives you perchloric acid, which is one of the strongest inorganic acids. So this being an acid, so this Cl2O7 is also known as acidic oxide. Now look at this, we have NO2, N2O3, N2O4, N2O5. We have three different oxides of nitrogen. In three different oxidation state, +3, +4 and +5. Now look at this, moving from +3 to +4, +4 to +5, oxidation state increases. As the oxidation state increases, or the number of oxygen increases, this acidic character of oxides also increases. So acidic character is acidic character. This N2O3 when dissolved in water gives you nitrous acid HNO2. N2O5 when dissolved in water gives you HNO3, nitric acid. So nitric acid is a stronger acid than nitrous acid. NO2 when dissolved in water, this gives you a mixture of nitrous and nitric. So while considering the acidic character of this nitrous and nitric acid is a stronger acid than nitrous acid. So that means for a particular element, if the number of oxygen increases in the oxide, the acidic character of the oxide also increases. So these are some of the basic features or the general characteristics of P block elements. In the previous lecture, we have discussed S block, we have discussed D block, and we have discussed D block. So considering this block classification, the periodic table looks like this. So we have look at this S block, then we have D block, then we have P block. So look at this, we have S block. So S block consists of group 1 and group 2. D block consists of 3 to 12, P 13 to 16. And below this main table, we have lanthanides, that is cerium to lutetium. Below this we have actinides, that is thorium 92, lawrencium 103. So we have these elements. So look at this, we have 16. We have hydrogen, lithium, sodium, potassium, rubidium, cesium. The last one is francium. Beryllium, magnesium, calcium, strontium, barium. The last one is radium. In this we have (13, 12). In this we have discussed. So this is S block consisting of this group 1 and group 2, P block group 13 to group 18, D block 3 to 12. So this is how the periodic table looks like. These elements I told you, these group 12 elements, these are not considered to be D block elements because they have completely filled D orbital. So look at this. In these D block elements, these forms a series within the transition series. So these are known as inner transition elements. This is F block. This forms in third group, D block 3 to 12, P 13 to 18, S block 1 to 2. So this is how the periodic table looks like. If you look at it, this is completely metal. This is also metal. This lanthanide actinides is also metal, but this P block consists of metals, non-metals as well as metalloids. So this is the complete overall picture of block classification of elements.